Hello students, this is Miss Dalton and this is video 10.4, Solving Rationals Part B. In my previous video we talked about the first method to solve rationals, which is using cross multiplication. But remember, cross multiplication only works when you have a single fraction equal to a single fraction. And so in this video we're going to talk about what happens when you don't have a single fraction equal to a single fraction. So when you don't have two single fractions equal to each other, you want to solve using the least common multiple. So if there is more than a single fraction on either side of the equation, use the LCM method. How to do that is to factor all terms if possible, multiply all terms of the equation by the least common denominator, and then solve the resulting equation. Remember, your resulting equation could be a quadratic, so you may need to use factoring, completing the square, or the quadratic formula. And as always, you always want to check your answers and be careful of the extraneous solutions. Okay, so here is our first example. We have 7 over 2 plus 3 over x equals 3. And so keep in mind we don't have a single fraction equal to a single fraction, so we are going to have to get the least common multiple. Okay, and so what we're going to do for that is you want to look at your denominators, and you want to look at all of the factors that are in your denominator. Now remember, when you have a whole number 3, that's over 1. If I look at my denominator, I have 2, and I have x, and I have 1. So my least common multiple would be one of each of them, unless I can turn one of the factors into the other with multiplication. So I'm going to have to take the 2, I'm going to have to take the x. Now I don't have to do times 1 because 1 times 2 would turn into the 2. And so my least common multiple is 2x. So what you're going to do is you're going to take each of the fractions, or taking the whole thing, and you're going to multiply by that least common multiple. So I'm going to multiply by 2x. I'm also going to multiply this fraction by 2x, and I'm going to multiply this fraction by 2x. What this does is this gets rid of your denominators, because if I'm multiplying by 2x, that's just 2x over 1, which means I can cancel off the 2's. And so that's just going to be 7 times x, which is 7x. In this second fraction, the x's cancel, and so I'll just have 2 times 3 with the plus sign, so that'll be plus 6. Equals, in the last one, the 1 doesn't really cancel, but it's just over 1, so you'd have 3 times 2x, which is just 6x over 1, which would be the same thing as 6x. And then at that point we can solve it like normal. We would subtract the 6x over to the other side. You would have x, and then we'd want to subtract the 6 over here. So we would get 7x minus 6x is x, and that equals the negative 6. Now you always want to plug it back in to see if it works. The main thing you're looking for is to make sure that it does not make your denominator 0. Well, in my original problem I just had x in the denominator, and x is negative 6, and so that will work just fine. Alright, let's look at example 2. We have 12 over x plus 7 equals 1 minus 12 over x. So again, we're looking at our denominators, and we're taking one factor of every denominator. So we've got the x plus 7 that we're going to take for our LCM. The 1 is not going to change anything, and then we also have this x. Now there's nothing that I can multiply times x to get x plus 7, so I do have to take the x as well. Therefore, when we multiply through, when I multiply this fraction, I'm multiplying by x times x plus 7. So you can see that the x plus 7 is going to cancel. So then I'll have 12 times x, which is just 12x, equals. When I multiply the whole LCM here, that's going to just multiply times 1. So it's going to be x times x plus 7. And then I'm going to go ahead and take that negative and put it up here with the 12. And I'm going to multiply this times x plus 7 as well. But the x's will cancel, so it'll really just be the negative 12 getting multiplied by x plus 7. At this point, go ahead and multiply out and simplify. So I'm going to have x squared plus 7x. Then I'm going to have negative 12x. And then negative 12 times 7 is negative 84. And that's all equal to 12x. Because this is a quadratic, I have to get everything on one side of my equation. So I will, in fact, have to subtract this 12x over to the other side. Now I'm going to go ahead and put it here. So what I'll have is I'll have 0 equals x squared. And then if you add 7x minus 12x minus 12x, it's negative 24 plus 7. So let's see, that would be negative 17x. And then minus 84. At this point, with the quadratic, you can either factor it or use the quadratic formula. I do notice that it factors pretty easily. It's going to be x minus 21 times x plus 4. And so after I set these equal to 0, when I set this one equal to 0 and this one equal to 0, then what I get for my answers are x equals 21 and negative 4. Okay, so you'd want to check and make sure that none of these are extraneous solutions, which I'm going to show that over here. So if we have 12 over 21 plus 7 would be 28 equals 1 minus 12 over 21. 12 over 28 could both be divided by 4, so that would be a 3/7. And 12 over 21 can both be divided by 3, so that would be 4/7. And then 1, if I convert that to 7 over 7, 7 over 7 minus 4/7 would be a 3/7 as well. So that one checks. Negative 4, you'd have 12 over negative 4 plus 7 would be 3. So that would be equal to 4. And that's equal to 1 minus 12 divided by a negative 4. So that would be positive 3, so 1 plus 3 gives you 4 as well. So both of these solutions check, and so both of them are your answers. All right, let's look at example 3. We have 7 over x minus 1 minus 5, which again, that 5 is over 1, and then equals 6 over x squared minus 1. First thing we'd want to do is we'd want to go ahead and factor that x squared minus 1 into x plus 1 times x minus 1. So our LCM that we're going to multiply through would be x minus 1 times x plus 1. Now I'm going to show you something a little different on this one because it's kind of a shortcut. If you multiply this times that LCM, the x minus 1's cancel, so really you're just taking that 7 and multiplying it by x plus 1. Okay, so if you want to think of it that way, whatever the denominator's missing, that's what you need to multiply the numerator times. Now the minus 5 is going to have to get multiplied by both of them. Now we could go ahead and multiply those back together and say that's x squared minus 1 to save us time. And then it's equal to 6 over, well, when I multiply this whole thing by that LCM, nothing's missing, so it's going to stay as just 6. Now let's go ahead and simplify. So that would be 7x plus 7 minus 5x squared plus 5 equals 6. So if I get everything on one side, I'm going to have negative 5x squared. Then I'm going to have the 7x. Then I'm going to have the 7 plus 5, which is 12, and then I'm going to subtract that 6 over to make that go away. So 7 and 5 is 12, minus 6 would be a plus 6. And that's equal to 0. Alright, so let's see if this factors. I would have to divide out that negative and make it 5x squared minus 7x minus 6 equals 0. So if I factor, 5x squared is just 5x times x. Now negative 6, you've got a couple of different options. If I try negative 3 and positive 2, let's say I put negative 3 here and positive 2 here, then that would give me 5x and 2, which gives you 10x. 10x minus 3x would give me 7x, but I need it to be a negative. So what I'm going to have to do here is I'm going to have to, let's see, erase that, and just change the signs. So make this a, let's see, I need the 10x to be negative. So I need a negative here and a positive there. That'll give me negative 10x plus 3x, which would give me the negative 7x. Okay, so there are my factors. When I set those equal to 0, I'm going to get x equals a negative 3/5, and I'm going to get 2. Because neither one of these give me a denominator of 0, they should both check. Go ahead and take some time to check that right now to make sure that they work, but I do think both of them in fact work. Okay, moving on to example 4. If we look at our denominators, we have x minus 3, we have x minus 5, and we have x minus 5. Now remember, when you do your LCM, I'm going to take that x minus 3, and I'm going to take the x minus 5, but I don't have to take x minus 5 again, I only have to take it one time, so then that's my LCM. So if I multiply this fraction times my LCM, the x minus 3's cancel, so I'm just going to have the x plus 3 in the numerator multiplied times x minus 5. Plus, then when I multiply it here, the x minus 5's cancel, so I would just have x times x minus 3. And then when I have this one getting multiplied, the x minus 5's cancel, so I'll have the numerator x plus 5 getting multiplied by the missing x minus 3. So now let's go ahead and multiply all that out. So x plus 3 times x minus 5, that gives you x squared minus 2x minus 15. If you don't, and I kind of combined a couple steps there, so if you need to work it out a little bit longer, you can. When I distribute this, that's going to give plus x squared minus 3x equals, when I multiply this, I get x squared plus 2x minus 15. So if I get everything on one side, I've got my x squared, that's 2x squared, but then I'm going to subtract this x squared, so 2x squared minus x squared is just x squared. Then if I have a negative 2x minus 3x, that's negative 5x, but then I'm also going to subtract this 2x, so negative 5 minus 2, that's going to be a negative 7x. Then if I have negative 15, and then I'm going to add 15 to the other side, that's supposed to be just a plus. Add 15, so that's going to give me 0. So that's all equal to 0. Well, this is going to factor x times x minus 7 equals 0. So that means that I have two solutions, x equals 0 and x equals 7. Now you'd want to make sure that all of those are okay. 0 does not give me a denominator of 0, and 7 doesn't either, so they both should check out and be okay. Okay, this last one is an example of an application problem, and I just want to go over it to make sure you understand how the equation is set up. It says the recommended mixture of antifreeze and water for a particular car is 50-50. Yoshi has 7 liters of coolant that is 40% antifreeze. How much antifreeze should he add to make the mixture 50%? Okay, so we're going to use this formula here. The percent antifreeze is equal to the total antifreeze divided by the total amount of mixture. Now, we want that percent to be 50%, which reduces to 1/2. 50%, of course, is going to be 50 per 100, so 50 over 100, which reduces to that 1/2. Now, it says that we have 7 liters of coolant that is 40% antifreeze. So that's where this comes from, is the 7 liters times 40%, so the 0.4. The total amount of mixture that we have is 7, okay? So this formula is taken into consideration right here. Now, how much antifreeze should I add? Well, when you add antifreeze, you're obviously going to add it to the numerator and the denominator, and so the plus x is added on to both the numerator and the denominator. And so now we just have to solve that problem. So let me go ahead and erase these marks for right now. And so this is an example 1 where you just cross multiply. So I'm going to multiply this, which would just be that 7 plus x, and set it equal to this, which if I do 7 times 0.4 times 2, that's going to give you 5.6. And then I distribute the 2 to the x, so that would be plus 2x. And so at this point, we're just going to solve it. So I'm going to go ahead and subtract the x to come over here. And then I'm going to subtract the 5.6 to go to the other side. So I would get 1.4 equals x. So that is how much I would need to add, 1.4 liters, in order to get that combination. Okay, so this is obviously the more difficult of the type of solving rational functions, so please just make sure you understand how I'm getting the least common multiple and then also what happens when you multiply the least common multiple. So make sure you understand those two things. Please ask questions if you need to on this section.